Now, for the non-photic Zeitgebers, this is a summary. I want to go over that in more detail. So, again, the SCN has synchronized. There's a systemic Zeitgebers, which include melatonin, which are optimized during the nighttime, cortisol, which peaks during awakening, and then you have a core temperature nadir at nighttime, temperature maximum during the day. Parasympathetics is active at night. Sympathetics is activated, particularly in the early evening, late afternoon. And also the heart blood pressure is reduced at night and increased during the day to correspond with these ANS changes. Now, when it comes to the non-photic Zeitgebers, and we're talking about peripheral clocks, we need to take into consideration another cycle that is important in our human body, and that is the anabolism and catabolism cycles. So anabolism is building of tissue, catabolism is the breaking down of tissue. And anabolism tends to happen when we eat, catabolism tends to happen when we're not eating. And so one of the biggest factors that are important for regulating this daily cycle of anabolism and catabolism is insulin. And this is a study done in 2015 by Frank Shear's group, I believe in Brigham Women's. And this shows you the circadian changes of glucose. So this takes a number of individuals, healthy individuals, where they're giving a meal. And you can see this is across, you can see it changes across in minutes, the glucose. And during the morning, you could see that the glucose does not rise at that much compared to the evening. So this meal is the exact same thing. And the reason why at the evening has a greater increase in the glucose for the same meal is that the insulin release is reduced in the evening compared to the morning, the biological morning. And so as a result of this, you can see that the glucose tolerance is about 17% lower in the biological evening compared to the morning. And this is attributed to about 27% lower and a lower early phase insulin response. And so this suggests that the pancreatic beta cell function is reduced in the evening. The other part is not only do you have a change in the insulin production, but you also have a change in insulin sensitivity. This was a study that involved 8 healthy men who fasted for across 57 hours, and yet they obtained continuous IV glucose infusions throughout that for 57 hours. And they obtained multiple blood tests. And you could see that this is during the daytime, and you could see during sleep, you could see this glucose increase as well as the insulin secretion rate. So even as the insulin secretion is increasing, the glucose is still increasing, so indicating that the peripheral tissues are lacking insulin sensitivity, particularly at night. And that might be due to a combination of increased cortisol and growth hormones, which are counter-regulatory hormones for insulin. That's one reason for why that is. But even so, early on in the evening, you could see that even with the same amount of insulin secretion rates, the glucose number increases. So even before sleep, you're starting to see that the insulin sensitivity is decreased. And so how is that summarized here? And you could see that the insulin increase occurs during the day, during anabolism, gets reduced at nighttime and the early evening as well. And then the insulin sensitivity is again greatest in the morning and day, but is reduced in the early evening. And leptin also has the pattern, which is leptin is adipose tissue hormone, is also secreted greatly in the nighttime. So this mediates a number of metabolic activity in the body, the insulin, and then the insulin increase, the reduction in the glucagon causes an increase in glycogenesis, lipogenesis, protein synthesis, all important for anabolism. And at nighttime, you have glycogenolysis and proteolysis and autophagy, which is important for catabolism. But because this insulin sensitivity, which occurs earlier in the evening, you will start to have more of a lipolysis and gluconeogenesis. So in the evening or so, you can have an increase in free fatty acids. And the reason that exists there is what your body is doing is preparing for the long fasting period that happens through the rest of the day. And so around this time, you could see an increase in the glucose and free fatty acids as well. So what happens if you have a meal here? So when you have a meal, you have the pre-meal hormone called ghrelin and the post-meal hormones, particularly glucose, insulin, IGF, and mTOR. These molecular markers are important for building tissue. So they're anabolytic, important for anabolism. And so it's important that you have these tissue present during the time of the day, which is responsible for anabolism. However, if you shift over your meal to the later time of the day, what you're doing is you're causing more of the catabolism effects of the body to be sort of scrunched up. And you could see basically a number of these catabolistic processes be reduced. In addition, when you're eating late in the day, the core temperature, because eating itself can generate heat, moves over the temperature to the right and then shifts over the core temperature nadir as well. And that leads to a number of changes to the whole system. So you can imagine that eating a meal later in the day really affects this cycle of anabolism and catabolism as well. And so there is a great study done by Sachin Panda. This borrows from his talk that he gave in 2022. He did a study involving mice, and he basically randomized them to either random eating or time-restricted eating, basically giving them the same amount of caloric intake for each day, but distributing them differently. So for the random eating group, they basically spread out the meals throughout the course of the day and night, and time-restricted eating was only given within 8 to 12 window, usually during the time when the mouse was active. And what it found out was that random eating led to a number of these metabolic disorders, whereas time-restricted eating actually was healthy. And this is a study, again, published in 2023. And you can see the ALF just basically indicates the random eating, and TRF is the time-restricted eating. And you could see the rhythmic genes here and showing the differences here. And you could clearly see that there was less arrhythmic genes for those who are getting random eating versus those who had time-restricted eating. And you could also see that changes is more evident across the course of the day. Again, matching sort of the peaks that we have seen before on my previous slide. And some of these make sense. So you could clearly see that when you have a more rhythmic eating period, such as time-restricted eatings, you have more expression of the digestive genes. And then you have triad of liver, muscle, and adipose, which are really important for metabolism as well. But interestingly, you also see that lungs and kidneys are affected by differences in meal patterns. And that's partly because the lung and kidneys is also moderated by the corticosteroids, which can be affected by these different eating patterns. And this is basically the phase peaks for different type of processes. And you can see this for the random eating and the time-restricted feeding. And this is at the nighttime. Remember, mice are nocturnal animals, so they're active during the night and they're feeding during this time. And you see two different patterns. Well, first off is that the ALF or the obesogenic diet disrupts the synchronies. And what it really does is it eliminates or distorts the phase peaks. So you could see, for instance, ketone metabolism or mitochondrial activity. You see this in the time-restricted feeding. You don't see this in the randomized eating. And then the other thing to note is, and then you could see that as well. You could see basically the phases are much tighter, and you have the existence of these phases in the time-restricted feeding in light blue. And with the random eating, you can see that the activity are sort of dispersed throughout the course of the day. But you also see that the random eating really affects the cross-system coordination. So you can see a lot of this metabolic activity for the time-restricted feeding occurs when the mouse is awake. However, you see that activity sort of occurring also during the nighttime for the randomized feeding mouse. And the other thing is that you're starting to see some conflicting messaging. So you see here, lipid synthesis is here and lipid catabolism here in the darker orange. And so you can see that they're separated. However, when you are in this randomized eating, they're starting to get overlapped. So there's conflicting messaging between the two. And so that is the reason why maintaining cyclical behavioral patterns are important to reinforce the anabolism and catabolism. And if you don't do that, you have some significant dangerous effects to your body. Now, what about exercise? I could talk about that real quickly. Now, exercise, importantly, both acts in response to the circadian rhythm and also can serve as an entrainer. What happens with exercise is that after exercise, you have an anabolic process after the exercise. So you have increased expression of IGF-1 and mTOR. And so if you're going to exercise, ideally you want this to occur during the anabolism stage of your day. And you can certainly do that during the rest of the day. And in fact, there's plenty of evidence that suggests that exercise is maximal. So that your exercise performance is best at around 4 to 7 p.m. And that happens for a number of reasons. First, it is coordinated with your systemic physiology. Your core temperature is maximum, your sympathetic nervous system maximum, your heart rate, blood pressure up. So you get good circulation, you're looser, and you're able to perform better as a result of that. But the other reason that it may be beneficial is during this early stage of catabolism, when the insulin sensitivity is going down, you have more free fatty acid and glucose available. And so what you're doing is you're enabling the exercise to absorb those material. And so that theoretically can reduce metabolic risk. So exercise itself has an important factor as well. So it's considering the timing of the exercise is really important.